All right, good afternoon, ladies and gentlemen, and welcome to this webinar on perspectives on ground segment digitalization. So organized by Euroconsult, and where I will have the pleasure to exchange today with Frederik Simoens, CTO of ST Engineering iDirect, and Paul Tilghman, Senior Director of Spectrum Technologies for Microsoft Azure Space. Approximately 40 minutes, where you're certainly invited to ask some questions. You will have an interface available for that, and we'll try to pick on some of those questions as we exchange. So before entering into the discussion, obviously the purpose of the Insights webinar series is to look at some of the disruptions, key dynamics happening in the satellite sector, and looking especially at disruptions that will make satellite connectivity and satellite-based solutions relevant in the ICT ecosystem through this decade. So, as everyone would be aware, one topic when talking about satellite network and space infrastructure is how to bring the solution and services in the end of the end users. And there's no way out of using a ground segment and the most efficient possible ground segment that could get created. While we are here today, for those who may not be familiar with Euroconsult, we have been providing strategy and technology advisory for customers around the world for a number of years now, and for the entire brace of space activities and enabled solutions, while we in parallel provide market intelligence, training for various organizations, as well as organize executive events. Coming to the topic of today, and just giving a bit of background as we're about to start the discussion, just looking at what's happening and what's converging now in the space sector. Certainly software defined is a buzzword in the industry, but it's also very much a reality. Just looking at the satellite component in last year, it's approximately or more than 70% of geo satellite ordered that have so-called software-defined payloads on board. And if not first generations, that for sure would represent all of the second generation NGSO broadband constellation currently under preparations. And I will talk further. Certainly this comes together with software-defined and increasingly virtualized ground segment, but I will keep that for the discussion. That comes also with a massive increase in capacities that will be deployed in the coming years. So as we estimate here, over 90 terabit per second, but also in terms of actual use of connectivity on a daily basis, the industry has certainly entered into the terabit era, and data consumption should increase at a fast pace. And it's not just obviously a matter of volume, but it's a matter of flexibility in terms of options for allocation, dynamic allocation of those capabilities for a variety of users and over time. Integration with terrestrial networks capability for the end user experience is certainly key, and I've no doubt that we'll come back to this through the discussion. Looking at 2 to 3 other directions for the industry, mobility actually could be considered from different angles. One could be from obviously the NGSO constellation moving against Earth, even if the end user is in a fixed location, or looking at the fast increasing number of mobile assets, obviously a lot today being ships and aircraft, but increasingly also looking at land options for trains or even other land vehicles. Applications, I believe certainly a need to increasingly look at the different application layers and to manage in a different way the various applications used by even a single end user. And as a final trend coming together with technology innovation is a transition in actually what's being offered by the different space organization, with different forms of new service integration, and certainly in the direction of managed services and whatever the definition of managed services that we could consider for just the next few years. And as I was mentioning, I believe that a lot of that is converging as we speak and for the next few years. But I also tend to believe, and there it's where I will open the discussion, that part of that future has to be enabled through adequate and innovative growth segment. And sorry, just stopping the sharing of my screen to turn now to Frederik and Paul to welcome maybe your first comment. And I would say first comment is in the trend we see in terms of transition to the cloud already and some of those items. What, just to start with that, what in your view it means for the space industry and how this can actually enable some of the transformations that I was referring to. So we would want to take those first few words. Frederik or Paul?
Pacome, maybe I'll start just as the cloud person on our esteemed panel here. So there's a couple of things that I want to just set the stage with. The first is really defining the cloud, because I think we all have a concept of what the cloud is. I've been at Microsoft now almost 3 years. What I thought the cloud was when I came to Microsoft and what I now know it to be are vastly different. So a quick education for the audience, we tend to think of the cloud as these megawatt class hyperscale data centers that exist globally, and then of course the network infrastructure that supports them. While that's true, there's really two aspects that are key that as we look at the impact of cloud in the space industry that we have to embrace. The first is that cloud isn't just those megawatt class data centers. Cloud also extends to the edge. It extends, as we'll discuss, I think, throughout this panel, to the ground segment site itself and compute infrastructure that's there. And so we call this hybrid cloud. And so it's really important to recognize the impact that hybrid cloud will make on the industry. But it's also to recognize that cloud is more than just an infrastructure. It's more than just a bunch of computers. It's a collection of services that you can composite together quickly to accelerate your business. And for the space industry, we can look at the lens of operators and think of things like Microsoft's Power BI platform or its AI tools, where you can garner insights about your satellite network that can make it more efficient and build those tools very rapidly. Or we could look at things like DevSecOps coming into the satellite industry. I think I get a new version of Office 365 once a week, maybe more often on my computer. That's a vast shift from when you used to get, an annual or biannual update of a piece of software. And so being able to sort of embrace that new development paradigm that comes along with cloud adoption, I think is going to be really important for the industry.
Thank you. And maybe Frederik, rebounding on that and your vision about it, or starting, obviously iDirect has taken a number of initiatives in that direction and towards virtualization. So just to start maybe with your vision and building on what Tom just shared.
Yeah, so I think the biggest shift for the space industry is that we're moving from a model that has been around since ages, where basically companies like us, the technology providers, we deliver equipment or we deliver appliances to our customers, being service providers, being satellite operators. And those customers, they take in that equipment, they host that, and then they build a service around it. And I think the biggest shift is that this model is changing both for us as well as for our customers. So we will gradually move away from delivering equipment to delivering technology, delivering virtualized technology. And our customers, they will no longer take in that equipment, but they will actually run those virtualized technologies on infrastructure that is not necessarily hosted by them anymore. So we rely on partners like Microsoft and other cloud service providers to provide that infrastructure on which we can deliver our technology. So neither us nor our customers need to worry too much about that infrastructure, because obviously it's not our core business to deliver servers and to deliver cloud abstraction technologies and so on. there are other players in the market that are much better at that. Neither is it our customers hosting infrastructure and running that and maintaining that is also not our customers' key focus. They should focus on providing end-to-end connectivity and providing the best quality of service to their end customers. So I think that's for me is the biggest shift, is moving away from this appliance equipment model to a more virtualized technology delivery model. And yeah, as Paul explained, as an add-on, you have immediately access to a whole bunch of new services that are out there in the cloud domain, let's say, the ones that Paul mentioned, like AI, other tools to manage networks, which can be leveraged as an add-on when making that transition.
Thanks. And coming with that topic of cloud, obviously comes, as you mentioned, the topic of virtualization. And I think, Paul, as we even exchanged earlier, you may consider that what is to happen now in the satellite industry is somehow what has happened to the mobile industry a few years back when thinking of network development and so forth. So
yes, I mean, but right now we're going through what I think, fingers crossed, we'll hope is an accelerated version of what we've seen the terrestrial wireless community go through the last decade. Exactly as Frederik mentioned, moving from appliances that were in telco data centers and telco edges to compute infrastructure. So we get the benefit of all those lessons learned. Microsoft is very active and has made large investments in 5G technologies for the wireless telco, the terrestrial wireless telco space. We now hope to bring all of those lessons learned and all of those technologies into this market and help the space segment, go through that same transformation, but more rapidly. And you, in your introduction, Pacome, you mentioned really that if we look at the satellites on orbit, going on orbit today, they're predominantly software defined. And so, when we think about virtualization, we think about a few key things. One, yes, it needs to put us on a path to lower total cost of ownership for operators that then, of course, reaps benefits for customers. But two, sort of embracing the software-defined nature and making the ground segment as flexible as the on-orbit space segment, and going from manually slewing beams on the Earth and manually apportioning circuits in a ground station to all of that going through completely dynamically hands-off in an automated fashion. And fundamentally, we know that this is a hard change. Microsoft went through this with the networking community when we were building the cloud, and we went from hardware network switches to software-defined network switches that are now so common. So we've been through this journey, in different industries before, and we think we can really help the space segments, move quite quickly through that same journey.
Thank you. And Frederik, so certainly you may want to elaborate a bit more on that kind of system approach. So with that question of the end-to-end flexibility or software-defined capability, and jumping on that, I believe that you've also put emphasis quite a few times where I heard you, we could exchange also on the question of standards that will be important for the industry as well to transition to what maybe the new normal in the next few years.
Yeah, so maybe first on that flexibility, I agree with Paul. I mean, there's, again, a big shift happening on the space segment side, where satellites that were launched 10 years ago, they were designed upfront for a specific purpose, a specific coverage, a specific application that they wanted to serve. Now they're completely software defined, and actually the business case can completely change over the lifetime of the satellite because that satellite is fully programmable. And obviously, if you have that flexibility in space, the least you can expect is to have the same flexibility on the ground. So our customers also don't want to deploy infrastructure for one specific purpose. If the business case changes, if the application changes, if the geographical coverage of the space segment changes, we need to be able to move that ground segment as well. And that's the flexibility that you get with moving that technology into a more cloud environment.
And if I see it correctly, actually, from what I could see, some first, let's say, concrete deployments of virtual ground segment was almost a bit earlier in Earth observation because of the nature of the very bumpy traffic with the data pass. And actually for telecom, it may have come just a bit after, because those new space infrastructure were also needed to fully leverage maybe what virtualized ground segment could offer. So as I see it, in the next 2 to 3 years, those two components are really working end to end if they want to have a global system capability.
Yeah, we obviously we don't like that telco is coming after Earth observation because I think
for once, I think it may be
pushing the boundaries, but you're completely right. I mean, Earth observation from a communication point of view, typically is very occasional use in the sense that they do a lot of processing and they download from the satellites at certain moments in time, not in a continuous way, which is the typical telco application, which is more 24/7 type of traffic, which while in Earth observation, it's more scheduled. It's more, but indeed, that same flexibility you also see it start coming in the telco world, where capacity is managed on a day-to-day and even within a day basis. When you, for instance, see airplanes moving from east to west and from west to east on a certain moment of the day, you see that the capacity will also completely move, and which can also imply that the ground segment, the amount of beams that are being created, the amount of beams that are being removed, is also becoming completely flexible. So indeed, that's something that is becoming more similar to what is happening already in the Earth observation world. Indeed,
Pacome, I'm glad you brought up Earth observation, because it's something that we're doing today completely virtual. Microsoft just announced, Azure Orbital Ground Station, an Earth observation service that we run, where we have both first and third party antennas that are directly connected to the cloud. And our network, our Microsoft infrastructure is all virtual. But as you mentioned, you're going from a very transactional 9 to 12 minute satellite pass, where you can even tolerate disruption. If you have a failed pass, you'll pick up at another ground station sites, in not too long, an hour maybe, to something that's 24/7, 365, highly redundant, needs to be able to handle failure. This will be a challenge for the community to really elevate what we're doing in Earth observation, blend it with what's happening in telco virtualization, and make the telecom portion of the satellite industry, ride this virtual wave.
Yeah, and understanding that we are talking space infrastructure, we're talking ground segment, but obviously moving forward, we might see as well more of the inter-satellite links or other forms of transmissions that will have to be managed in a dynamic way, kind of end to end, I believe. Maybe jumping back on the question I had a bit earlier about standards, because obviously part of the question of the integration as well of the space capabilities will be also the ability likely to have a more standardized approach, and the ability typically in 5G to be more embedded with terrestrial networks. So I know actually both Microsoft and ST Engineering iDirect have been involved in either 3GPP or either in the digital IF interoperability consortium, DiFi, maybe easier to say it that way. So just maybe giving some perspective on the stakes or criticality of those standards in the transition that you anticipate.
So I think there's several aspects of standardization and why standardization is important. One is cost. So, ultimately standards help us get commodities of scale, and without commodities of scale, software can be just as expensive as hardware. So virtualization isn't a panacea in and of itself without standardization that comes along with it. And, there's, at least as we're seeing it, there's two key aspects. There's adoption of standards from adjacent industries, 3GPP, like you mentioned, and Release 17, I think, of the 3GPP standard is a really good example of the blending of terrestrial and non-terrestrial telco, and starting to see, support for non-terrestrial networking, coming out of these larger terrestrial standards bodies. But we also have places where, we need to innovate on our own, fill the gaps, embrace that space is unique. You say DiFi, I say Diffie. Maybe we can, maybe that'll be an action we take up in the consortium, is to figure out the pronunciation. But that's an example where as an industry we came together. Microsoft and iDirect are both part of Diffie that Microsoft co-founded, and it's a recognition that we needed one standard way to talk to digitizers and one way to transport RF data as digitized into the cloud. So it really, standards really do need to be a blend of both adopting what makes sense that's in market that can get us economies of scale, but in finding the gaps, also recognize that as an industry we need to band together and still standardize within those gaps, so that we maintain those economies of scale.
Yeah. Yes, and actually for Diffie, then I think this year has also seen the convergence of two actually working groups that used to be separate, and then it's been aggregating a larger number of stakeholders. So Frederik, maybe as well your perspective and from iDirect standpoint on that contribution to the standard definition.
Yeah, well, actually, like you said, there were initially two initiatives being started up exactly at the same moment in time, just to show how much interest there was. But of course, we realized that if you want to standardize, you need to have one standard, not two. So we immediately merged those initiatives. And I think it's a very important initiative because we're trying to replace something that has been around for a long time, which is basically an analog co-op between modems and antennas and things like that. So we want to replace that with something digital, and obviously we need to make sure that all players in that field, be it RF manufacturers, BUCs, LMBs, as well as modem vendors, which also can talk the digital interface, whether that modem runs on dedicated hardware still or whether it's completely virtualized and running into the cloud. You need to have a common understanding of how those samples, how those RF signals will be transferred in a digital way. So I think what we're doing now, what we're seeing, and what you will see also in the next coming months, is vendors starting to adopt and to use those and support those standards on their products. That will be a very interesting moment then when you will see these demos, and then we will also launch a few in the coming months where we will demonstrate that our modem technology can talk over a Diffie interface to an RF player's infrastructure, so that you can actually realize that promise of a digital teleport, which is basically a teleport without any analog cabling, without any RF switch matrices, without any splitters, combiners, amplifiers, all stuff that works well, but is very painful to maintain, and mistakes are easily made. If we can digitize all of that, it will simplify those teleports a lot, and also will create a lot of opportunities because it will be much more easy to, for instance, reroute traffic from one antenna to another. So there are plenty of advantages, apart from the fact that you can run everything with respect to the modem technology into the cloud. I think there's some other advantages related to the fact that you can digitize that teleport. So that's why we're obviously fully engaged also in that Diffie standardization and adopting it on a product.
Yeah, and understanding, well, I may elaborate a bit on the future transition path. I assume that at teleport level, this will have to come together actually with the consideration of regulatory or security or concern or specific clients. So it will be that ability to both move to a virtualized environment, but potentially as well manage different components that you may have in the same teleport actually, or same facility. So the two shall kind of work end in end, I believe, depending on customer or end user expectations using the networks. Maybe turning also to obviously the partnerships that Microsoft, Azure, and iDirect have announced already well, some months ago, or not so long, but it's like a couple of months already, almost now. You know, what has been, and maybe just to give a quick summary of the rationale or direction for this partnership, I believe, some of the thinking behind where you felt it's important. And maybe on top of that, then Paul as well, I know that Microsoft had that ecosystem view at building such partnership in different directions. So happy to hear you elaborate on this. So,
Frederik, do you want to start and talk a little bit about?
Frederik, please.
Yeah, no problem. So yeah, obviously it's our vision to gradually move our technology into a cloud environment. And one of the most difficult things to do in that transition is the modulation and demodulation part, which is highly computational intensive, signal processing, error correcting coding, things that are, let's say, very complex, require a lot of resources if you want to run them on, let's say, a plain CPU type of architecture. So what we wanted to demonstrate is that you can actually achieve high throughput, and that's important, because when it's low throughput, it's easy, but we wanted to demonstrate that you can do high throughput modulation and demodulation in a cloud environment. And we partnered with Microsoft there to demonstrate that you can actually run iDirect, modem, and so modulator and demodulator technology in a Microsoft Azure environment, where we actually make use of the hardware acceleration that is present in that cloud environment. So it's not a pure CPU type of environment, it's more a hybrid environment, but it's completely running on, well, it's running on Microsoft's cloud. So there's no equipment, there's no hardware involved anymore from iDirect. So that, I think that's an important proof point that most computational intensive part can actually move to a cloud environment, and everything else should be easy compared to that. So I think that's what we wanted to demonstrate. And yeah, once we have done that, we will also start productizing some of our technologies into a cloud environment, starting with the most trivial things, which we basically already do today. It's like the network management software can be run in a public cloud environment. Also, the network processing stacks will then move into a cloud environment. And then finally, also the baseband parts of the modulation and demodulation will move into a cloud environment. And that's what we're prototyping, or that's what we're demonstrating already today.
Yeah, so it's, I think, Frederik, it's almost been a year since we've announced our partnership. And you know, what we decided very actively early on was, yes, we tackle the hardest part, because yes, there are lots of aspects of virtualization that, you know, move beyond just converting hardware to software. You know, when you actually start to take advantage of the cloud environment, as Frederik mentioned, you need to tap into elasticity, which is a key concept in cloud, that if you're not using resources, they can contract and, you know, return to the resource pool, that you have a service-based architecture. But those are all, you know, very easy hurdles to tackle, and some of them iDirect is already tackling after you've tackled the biggest and hardest problem, which is virtualization. And going back to Earth observation, you know, we have Earth observation modems that run at lower data rates that are all software today. And what was really important in the work that we've been doing through our partnership is to get to that high data rate, is to get to that FPGA accelerated, because ultimately, you know, embracing this from a telecom sense as opposed to Earth observation sense, it's really important that we can do those full data rates. Now, one of the things that Pacome, you mentioned that I want to touch on is really looking at this through the lens of an ecosystem. So Microsoft has done this digital transformation in lots of different industries. And the key is always for Microsoft, looking at ourselves as a platform company, looking at ourselves as how we support a whole ecosystem, if done right, we want to support the entire space industry and lift the entire space industry up, not just one specific player. And the way you do that is you work with, great companies like iDirect, the people that already support the ecosystem of that industry, and we help get them onto Azure. We help accelerate their applications. We make sure that, where and when we find issues where the cloud doesn't actually, support those applications in the way it needs to, we go address and, basically build additional capabilities in order to accelerate what we're doing. And so at the end of the day, what's really important for Microsoft is that we have not just iDirect and the rest of the vendor community on the Azure cloud on our platform, so that we have that complete ecosystem that all the satellite operators will need ultimately to build these digital ground segments that we're talking about, build them efficiently, effectively.
Thanks. And, coming back and maybe to not the start of the discussion, but thinking out of the development to the benefit of end users, or trying to get a few examples of what will be enabled typically to certain use cases, and I'm sure certain of them are already on the testing, if not available already. But thinking also what you mentioned about the edge capability of some of the new flexibility capabilities that will be offered for end users. So would be happy to hear from you, Frederik, and Paul, on a few thoughts or a few actual use cases where you see concrete benefits for certain of the enterprise customers, or maybe even government customers, as certainly we're working in a very large, servicing a very large breadth of end users for satellite connectivity.
So, Frederik, maybe I can pick on one that I think we actually put in our demonstration video, and that's public safety and justice, first responders, people that need to establish connectivity where connectivity either isn't present. Let's say wildfires tend to be fought in areas that are very remote and not high connectivity rich, or after a disaster, infrastructure, can be wiped out and offline for days, weeks, months. And so it's important not just to be able to bring satellite connectivity into those areas to reestablish or to coordinate, but to do it rapidly, right? So if we go back to this idea that, we actually need to rapidly establish service. It can't be deployed over, a time frame of days or months. We need to push a switch and have it, very, very rapidly. And so that's a great example where the kind of dynamics that we're trying to enable with virtualization and with cloud really come through, so that the services can be created quickly. And if we go back to, the fact that the cloud is really a platform, a service platform that you can build new capabilities on, you can also look at that as how do you compose together additional capabilities that the cloud has in order to rapidly build the right service set for the customer. So maybe the customer doesn't just want layer 2 service, maybe they want layer 3 service, and then maybe they need a particular network connectivity pattern. They need a certain set of virtual networks, they need firewalls, they need security infrastructure. All of those things are virtually deployable in the cloud environment. And so you can go from that core, layer 2 service to a very complex enterprise network architecture very quickly by deploying additional services on top of this virtualized ground segment in the cloud.
Okay, and if I hear you well, that would effectively also transform some of the, let's say, legacy way of working that was quite largely about typically a fixed 3-5 years contract with essentially constant capability over that time frame, to something much more upgradable through the period of time, depending on the offer.
Absolutely. So there's maybe 2 aspects to that. One is, technologically, can that connection that you've procured change over time. And I'll go back to my comment about DevSecOps. Yes, like we can think about how we repeatedly change and deploy the infrastructure around that connection to build really not just the connection itself, but from Microsoft's perspective, we like to think about this entire industry as, you're trying to move data from somewhere on the planet to the cloud to generate some insights, right? And so it's about that entire service chain and not just about the connection in the middle, and really being able to look at that end to end as a cloud resource.
Sure, thanks. And Frederik, please, yeah, from.
No, I was also going to say again, if you look at it from what our customers, what the satellite operators, what the service providers, what they host when creating a connectivity service, I think a lot of that equipment, what it is today, it's not only the satellite communication platform, but it's everything around it. Paul was mentioning, or you were mentioning, the layer 3 services that you want to create around that. Deep packet inspection, maybe an SD-WAN layer, maybe an integration into 5G core network. That becomes a lot easier if all those technologies can run on the same platform. I think that's the easiest way. And if you later on want to change for something else, you just stop the subscription of that particular service, and you use another service to kind of create a new end-to-end connectivity for your customers. So it's that flexibility, not only for the satellite communication platform, but for everything you need around that to build that end-to-end connectivity service towards the end customer.
Thank you. And I'm just keeping an eye on some question we received, and actually one that may be about deployment and starting to look at the next few years. So one is really about the capability building standards, some items we mentioned already. Some of it is also obviously about the transformation of facilities or teleports and then process work and so forth. So one question I have, but where I may enlarge even the topic a little, the question is about the maximum length inter-facility links can have in digital IF architecture, but maybe even a bit beyond that. Obviously, in places, it may need to rethink a bit the topology of actually antennas next to a data center, or what is a teleport about, what connectivity is needed in those various locations. So what is your view of what's needed as well there for the network to be progressively actually transformed into that new norm, maybe?
It's a good question, because indeed you need to look at the entire topology of your satellite communication network. So Diffie has a lot of advantages, as I explained. It has one drawback, is that the amount of throughput you need, or the amount of megabits you need to transfer a certain amount of information bits, let's say, is much higher than when you're just sending out these information bits. That's because you kind of digitize a waveform, and you need to do that very, very accurate. So that comes with, let's say, a higher number of bits per sample, just to go a little bit technical. So and as Paul mentioned, that's where you need that hybrid cloud environment. You don't want to transfer data digitized from a teleport a few hundred kilometers to a centralized data center, because that would be very costly in terms of transfer cost, in terms of throughput that you need. So you really need to process these at the edge, close to the teleport. But that's where you have this distributed architecture. So the typical modulation, demodulation technologies or functions, you would run very close to the teleport. And that's where you also terminate then the Diffie interface. And that can run on any type of hybrid cloud environment. And then the other functions, the more high layer network stacks, those you can centralize. But the communication between that modulation, demodulation, and the network functions is already at a decreased rate, because you have already processed the modulation and the demodulation at the edge, close to the teleport. So these are things to take into account. I don't think there's a technical limit in how far you can transfer a Diffie signal, but it's just there's a commercial aspect as well. You don't want this to become excessively expensive, of course. So that's why you need to make sure that you process the right type of function at the right geographical location.
I think, Frederik, you hit the nail on the head. And in fact, when we look at the cloud, the hybrid cloud as a architectural platform and how you distribute, ultimately what we're going to end up, today is a hardware modem appliance. In the future, we'll end up calling it either a virtualized or a cloud native network function of some kind. Our approach is that, those can be deployed in the hyperscale cloud back in our, large regional data centers or all the way out at the edge. And, our goal and what our platform does is it really abstracts, where those actual network functions are deployed. And so then, yes, you can start to fundamentally shift the topology of a ground segment, but you do have to overlay cost on it. And, Diffie, if you look at the actual data bits encoded versus the digitized waveform, there's a 10, depending on how complex the signal is, there's a 10 to 40x increase in data volume to move the digitized data. And so today, absolutely, we see that the cost causes things to swing in the direction of demodulating in a hybrid cloud environment at the edge. But then, your choice of where to put the rest of that networking stack, as Frederik said, is some of it could live at the edge. It could all live in the cloud, some combination thereof. So it really does introduce some really new, interesting topological decisions for operators as they look at how they build their ground segments.
And I believe, obviously, that the level of maturity of satellite organization obviously can vary depending on their size, number of space infrastructures they have. So I believe that a component of that is also try to work with them or end to end. So to even help them or work with them to think of those topologies actually of what's required in what would be their ground facility of 2025 or even before.
Yep.
I see that also as one of our roles is to help design these digital teleports and how the topology should look like. Because I think we at both companies like Microsoft and ourselves, I think we have the unique knowledge about how to build these type of networks, how to transfer those analog signals in the digital domain, and this is certainly some kind of service I think we need to offer to our customers as well to help them build those future teleports, let's say, or those future satellite networks.
Thank you. So I see that we're already pretty close to the time we had for our discussion today. So before closing still, and looking maybe at the next 2 to 3 years, or what you see as being on the critical path, or just trying to project ourselves 3 years out, what is your expectation on that journey for the space industry over that time period?
So maybe I'll start, but I think we should look at 2 time horizons. And so let's start with 2 to 3 years, and then we can look, what does the next decade look like once we clear that 2 to 3 years. But the next 2 to 3 years, I think, I'd put sort of the criticality around demonstrating or moving from sort of demonstration, proof of viability to product grade, to hardened services. And the reason I say that, I love that you introduced Earth observation into the discussion earlier. Like we know how to demodulate signals in software. Like this isn't in and of itself a hard problem. The challenge in front of us is to bring those capabilities in a hardened fashion into a highly available computing substrate. So what happens when inevitably a digitizer fails? How do we dynamically reroute that signal to a new virtual modem to be able to make sure that customer doesn't get impacted? What happens if a computer fails, right? How do we make sure that we have either the ability to rapidly or on demand create new virtual modem resources to service that connection? It's handling that shift from, yes, it is technically feasible and doable, to how do we actually do it at scale? How do we not just do it on one computer, but how do we do it on compute clusters for an entire digital infrastructure around the globe. And so I think that's the progress that we're going to make as an industry in the next 2 to 3 years, is we'll climb and summit that mountain.
Thank you. And Frederik, maybe embedding into this question a very pragmatic just that popped out, so it would be final one I can take. But with regards to DeFi or DeFi products, so leveraging the standard, when do you think users can anticipate to have DeFi capable products where the standard's really integrated? When do you think such products could be available into the market, kind of?
Yeah,
so we're talking about,
I think it's also in that same time horizon, 2 years, maybe 3 years. And the reason I'm saying that is because to really fully benefit of DeFi, you need to have it supported on all parts of the ecosystem.
Yep.
You can, if you have digitized your modulator, but your RF equipment doesn't have a DeFi interface, then you need to put a digitizer in between, which makes it a complex setup. But I think in time frame of 2-3 years, you will see antennas supporting a digital, maybe flat panel antennas. Those are the easiest ones because they are typically already processing the signals in the digital domain. So they will have digital interfaces, but then later also the more traditional components like bucks and LNBs. And once you have that, then you really have a lot of value of using it. I think the digitizer is a good intermediate solution, but the really end goal is to go digital all the way to the outer unit, all the way to the antenna. And so once all those players have it, then I think is when you will actually see commercial traction and you will see it being used in operations.
Thank you. So I guess that may be our final word. I'm sure the discussion will be ongoing and we can certainly have an update earlier than in 3 years on the matter with everything happening. So just as we're about to close, just to let, just to tell that this session obviously has been recorded and will be made available to all the subscribers to this webinar, and maybe even beyond that. As we close, would like certainly to thank very much you, Frederik, and you, Paul, for sharing your insights today. That was very interesting, including for myself, where I learned a lot, certainly. So looking forward to the progress of both usage of cloud and overall virtualization of ground segment and of the global space capabilities. Thank you very much, everyone. Goodbye.